All right, this is Mr. Peterson with part 2 of the Energy Efficiency and Renewable Energy screencasts for AP Environmental Science. I usually aim to make these screencasts somewhere in the 15 to 18 minute range, but it seemed like there was just too much I was going to leave out that really needed to be presented, so I had to break it up into 2 screencasts instead of one really long one. If you want a rough simulation of college, play both of them back to back and try to take notes without the outline and get as much of the information I say recorded on your paper as possible without hitting pause. That should be about a whole 50-minute class's worth of a lecture, and your test will feature questions over a seemingly completely different set of material, so enjoy high school while it lasts. Now, we left on part 1 with the idea that the world is going to have to shift renewable resources, or renewable sources of energy, because there simply isn't any other long-term option. So, for this part of the screencast, we'll go through each of the renewable energy options and learn more about them as we go. And first up is solar energy. There are multiple applications for solar energy because it is useful in many different ways. First up is heating buildings and water. This house is an example of passive solar design. It's called passive because there are no moving parts required. The broad section of south-facing windows allow the winter sun to reach into the house to warm it up. The floor is made of stone or ceramic material that absorbs the heat during the day and releases it at night. The curtains can slide down to cover the windows at night, keeping the house warm. In the summer, the overhang from the roof shades the windows and keeps the direct sun out. Now, this is some extreme architecture here with this much window space, but in reality, I picked this picture because it's pretty and really just having some normal-sized windows on the side of the house with a proper roof overhang can get the same job done. Active solar heating involves movement, and it's usually achieved by pumping a fluid up into a solar collector situated on the roof of a building. As the fluid moves through a serpentine line of tubing, it is warmed by the sun. When it comes back into the building, the collected heat is used to heat the air or water for the building. Both of these approaches can heat buildings and water with renewable energy, but it's also possible to cool buildings using wind energy, which is really a result of the sun's energy heating the earth unevenly. Buildings and homes can be constructed to make it possible to make natural breezes flow through the building to ventilate it, carrying away excess heat. This wouldn't work very well in the months of July, August, September around here, but it would work quite well for the spring and fall months when the temperatures are very moderate. In some parts of the world, this method works well almost year-round. I went to Hawaii, and the hotel lobbies were open year-round. There really weren't any doors. They were just open courtyards with the rooms on top of them, so the breeze blew and kept them cool year-round. Solar energy can also be used to produce extremely high temperatures, which are used to generate electricity. In this array, called a heliostat, the curved rows are made up of hundreds of mirrors, which can all rotate automatically to reflect the sun on the tower in front of them. Cool water is pumped up into the tower, and when it flows through the section heated by the mirrors, it turns into steam, which is then piped back down and used in the traditional way to spin a turbine and electric generator. Actually, last night I just watched a documentary on this on Netflix and went over the unanticipated consequences of this sight on birds flying in the concentrated UV rays. It was essentially cooking them in mid-flight. And then it went over the way they went about solving this problem. It was very interesting. Now here's a solar cooker. And they are smaller versions of the same thing, and they're used to cook food and heat water without any use of fossil fuels. These are great for remote areas like this one, because now the people living here don't have to cut as much firewood in order to cook, which preserves the forest. Freeing up that time that people used to spend just collecting firewood is great for the economy too, because people can now spend more time in other work, raising their standard of living. It also reduces local air pollution because there's no smoke being produced, and these are highly efficient. Can cook actually pretty quickly. Last up is the production of electricity directly from solar power. These are photovoltaic cells, named for the fact that when sunlight strikes them, they release electrons which flow together to create an electric current. There are some advantages and disadvantages to using solar power for electricity. First up, solar power only produces electricity when the sun is shining. Modern solar panels can function somewhat when it's cloudy, but they are hopeless at night. There's a possible solution to that, but it's coming in the hydrogen power section. Another disadvantage is that electricity generated from solar power is still quite expensive compared to other sources. The price is starting to come down as more and more people are buying and we can bulk make these, and the technology is getting better, but the high-tech equipment needed to manufacture the panels or mirrors just isn't cheap. But it's getting cheaper, and hopefully it'll start becoming more mainstream. An advantage of solar power is that it is virtually non-polluting, after the environmental cost of making the panels is accounted for. Another advantage is that it is easily scalable, meaning that power companies can have huge solar installations, but homeowners can have smaller ones located on their roofs. In contrast, coal-fired power plants are pretty gargantuan and can't be scaled down to home-sized versions. An exciting development over the past few years has been the rise of the Gridtied Solar movement. In previous decades, homeowners who wanted to go with solar power had to install the panels and enough battery capacity to store enough power to last through periods of low sunshine. That cost, plus the fact that when the batteries were depleted, your lights didn't turn on, sort of dampens people's enthusiasm. Enter Grid-Tied Solar, where a house can be powered by regular grid electricity and solar power. The picture shows two electric meters. The old one on the right measures power entering the house from the grid. The newer one on the left measures electricity generated from the house's solar panels that is fed back into the grid. On really sunny days, the house can generate its own solar power and not use any of the grid. At night, it can draw power from the grid and pay for it. While the homeowners are at work on sunny days, it's even possible for the house to generate enough excess electricity, and the utility companies are required by law to purchase the excess power, and get this, at a rate higher than they can sell power back to the homeowner. So, there's really no downside. The utility company wins because they don't have to fire their power plants as much, and they can sell that renewable energy they just bought to someone else for a premium. Next up is hydropower. Traditional hydropower involves building a dam across a river and allowing the water to flow through and turn the usual turbine generator assembly to make electricity. While I remember growing up thinking this was the solution that would save the world, it really hasn't come to be. There are a lot of problems with hydropower, from the fact that the reservoirs fill up with sediments as water sits, and the fact that it doesn't rain upstream of the dam. Then power production can be shut down because there isn't enough water. But there are advantages, including zero pollution, and a very constant amount of power production, as opposed to, let's say, solar power at night. Some ideas that are currently being tested is using the power of waves and tidal water flows through to generate electricity. This is an artist's rendering of turbines placed on the river floor. Such systems have yet to come online in real capacity, but it is a very interesting area of development. Now, what is growing is wind power. Wind is produced by the sun heating the earth, having that hot air rise, and then air from nearby rushes into the area it replaces it. Wind farm like this one can be constructed in areas with reliable wind, so that the energy of the moving wind, I'm sure you can guess it, turns a generator to generate electricity. Advantages of using wind include that it is highly efficient, generates low-cost electricity, and has nearly zero environmental impact. There is some concern over whether the turning blades can kill birds, but other than that, they're about as environmentally friendly as you can get. I've seen farms like this across the western United States, and I have to tell you that there's something mesmerizing about watching all the turbines spinning in the wind. But there are those who think that they're ugly, and to tell the truth, they do generate some noise as they spin. Another disadvantage is like the solar night and day problem. They only generate electricity when the wind is blowing. There's a solution to that one again, but it's in the hydrogen section. In a strange twist, wind power has turned out to be a benefit to many farmers and ranchers. As each turbine is really quite large and somewhat noisy, sitting them near residential areas runs into the NIMBY or not in my backyard problems. So, wind power utilities often pay farmers and ranchers to allow them to install the turbines in their fields and pastures with a cute acronym for it. Put it in my backyard, or PIMBY. The royalties on each turbine are significant. One turbine can generate $300,000 worth of electricity a year, and farmers can receive around 1 to 3% of that, so anywhere from $3,000 to $10,000 a year. Per turbine. You do the math. Can I get some turbines over in my land, maybe? That'd be awesome. It's not directly related to electricity production, but wind power is making a comeback in some unexpected places. This cargo ship is using a sail to supplement engine power, allowing it to throttle back the engine some, which saves fuel. It might not be much, but it can add up if you're crossing an entire ocean. Next up is biomass energy. Biomass is plant animal waste that can be burned directly as fuel, or converted into a liquid or gas form called biofuel. Biomass has always been used as a traditional source of power ever since the first fire was used to cook food and heat a dwelling. But in recent years, biomass power plants have come online, using various sources of biomass like waste wood chips, crop waste, and animal manure to burn in the process of generating electricity. Now, burning high-quality lumber isn't a great idea, but when you look into the picture, you notice that most of the pieces in the pile are really the outer bark of the trees, pieces that couldn't really be cut and shaped into anything in a lumber yard. Also, this pile of logging waste technically qualifies as biomass, and it would burn just fine and often is burned on the logging site. Instead of burning it where it was cut, it's just transported and burned somewhere else when the added benefit of generating electricity can be used. Biofuels are liquid biomass and are usually produced from plant materials such as vegetable oil in the case of biodiesel here, and corn in the case of ethanol. These fuels have some advantages over traditional fossil fuels because they can be grown anywhere as opposed to relying on certain areas of the world that can produce large quantities of oil. Second, if the crops to support biofuels are grown just as rapidly as they are used, there isn't any increase in CO2 emissions because the growing plants absorb CO2 from the air. That's different from fossil fuels where we've released CO2 that took millions of years to be absorbed and turned into fuel. Last, biofuels can be used with little to no engine modification to existing vehicles. Disadvantages include lower mile per gallon efficiency for vehicles using it and the elephant in the room, the fact that growing crops for biofuel production competes with the primary reason for growing crops, food. Also, growing crops uses fuel to run the tractors and trucks to haul the product, so that lowers the overall energy efficiency of the final product. And let's go into geothermal energy, or the heat of the earth. This graphic points out that once you dig a few feet down into the earth at a constant temperature of about 55 degrees Fahrenheit. That's a reason dogs dig holes under the house and go lie down. On hot days, it helps cool them off. So geothermal heat pumps take advantage of that in the summer by pumping heat out of the house like a normal heat pump AC does, but instead of releasing that heat into the air that is quite hot and makes it hard for the heat pump to release the heat, the fluid is pumped deep underground in a long line of tubing. The cool ground absorbs the heat, which is then pumped back up above the ground to absorb more heat. It runs in reverse during the winter when the cool fluid is pumped underground and warms up to 55 degrees, and then the heat is in the fluid can be extracted by the heat pump and used to warm or cool the house, depending on the time of year. And then we have hydrothermal reservoirs that generate electricity by a deep source of geothermal energy. These stations pump water down into areas where the geothermal heat provided by magma is much closer to the surface than normal. As the water heats and turns into steam, it is then extracted by pumping it above ground to turn a turbine to generate electricity. The advantage of the system is that there's very little pollution, and the electricity is very low cost. Problems include that the heat underground has to be accessible, and in most areas it's just too deep to access it affordably. Plus, it can be exhausted by overuse. Continually ejecting cool water and removing steam can cool the local area of the bedrock, considerably reducing the plant's usefulness. Now, areas such as Iceland use this extensively. There's even individual restaurants that use it to cook their food because the heat is so close to the surface. The last source of power is hydrogen. As I mentioned earlier, hydrogen fuel cells combine hydrogen gas with oxygen gas to produce electricity, and the waste product is pure water. Hydrogen has three main problems with its widespread use. First up, hydrogen doesn't exist in pure form much in nature. It's combined with water and other compounds, so it takes energy to remove it from those compounds and isolate it in pure form. There's no getting around that one. Second, fuel cells are expensive. They're a high-tech piece of equipment. They are coming down in price, but it's still not mainstream technology. Last, a hydrogen power system can be just as polluting as any other system, depending on the source of energy used to produce the hydrogen. Now, here comes the part of hydrogen that solves a lot of problems with other renewable resources of energy. Remember, the night-day problems faced by solar and wind having to blow problem of wind energy just makes it a problem. Well, it's possible to apply the electricity to water under controlled circumstances in a process called electrolysis. And it breaks water down into hydrogen and oxygen gas that can be collected. So, even though a solar or wind power plant can generate electricity only in the proper circumstances, it is possible to store excess electrical capacity by breaking down water and storing hydrogen. When it's dark or the wind isn't blowing, that hydrogen can then be used to generate electricity in fuel cells, for long enough to last until the sun or wind is up again. That's really hard to store vast amounts of electricity in rechargeable batteries, but we're going to see more of this kind of alternative energy storage in the next few decades. Now, the future brings with it many challenges, but one of the definite things that will happen in the future is a shift to more sustainable sources of energy. It has to, because there's just no other choice. One likely shift over the next few decades that's really already happening today is the shift from large power plants to a more distributed system of power generation, where multiple smaller sources of power all work together to supply our needs. Seen here. Natural gas plays an important role in the transition to renewable energy, both because we have a pretty good supply of it, and it's the least polluting non-renewable way to generate electricity. Fossil fuel pricing is important too, because if prices are too low, whether by government subsidies or economic forces, it reduces the desire to switch to renewable resources. It's a debatable topic whether fossil fuel prices should be artificially raised to stimulate renewable energy growth, but the fact remains that one day all fossil fuels will be unaffordable. It's just a question of which path do we take to get there. And last up is the transition to renewable sources of energy to consumer education. That might include the government sponsoring TV commercials touting renewable energy, or something as simple as this. The power company responsible for this area decided to put a single solar panel on each telephone pole in its entire area, instead of building one huge solar array somewhere else. Every person driving by every day sees these things and thinks, wow, that's pretty neat, and might be inspired to do something similar, even if it's on their house, and no matter how small it is, it can all add up. And that's it for this screencast. Thanks for watching.